Welcome to 10.1, video 1 of 2. The topic here is parallel lines, skew lines, and parallel planes. And we got 4 boxes to kind of jump in here. So number 1, we're talking about some definitions. So parallel lines, as we should have already noted from before, are two lines that never intersect, that are coplanar. So we should know that the word coplanar means that they're in the same plane. Remember that from last unit. So in this picture over here, 2 examples of lines that are parallel and coplanar would be line M and line N. So those are 2 lines that would be coplanar. So they're in the same plane and they are parallel because they never intersect. Okay. Skew lines, this is something new. Skew lines also never intersect. Okay, so there are 2 lines that never intersect, but they're not coplanar. So what we mean by that is, like, let's take a look at like line K, for example. Here is line K, and here would be line M. Now these 2 lines are never going to intersect, but they are from different planes. So we can put those in here. So we can say line K, and this is our symbol for line, remember? And then line M, for example. Now there are others, right? I could have said K and N. That could have also worked as well. But that's a new word for us. So parallel lines versus skew lines. So skew lines never intersect, but they happen to also be in different planes. Okay, then lastly, a parallel plane. 2 planes that, again, never intersect. So that should be a theme, right? And in this case, if my 2 planes would be sort of this top plane here, right? And this sort of bottom plane here that goes behind it and underneath it. So they will never actually intersect. So for us, that would just be plane T, which is then parallel to plane U. And that's the symbol, in case we don't know. 2 lines right next to each other, that's the symbol for parallel. Okay? That's everything for box number 1. Let's do an example together next. Here's example number 2, or for box 2, it says, think of each segment in the figure as part of a line, and then which lines or planes appear to fit the description. Okay, so for part A, we're looking for lines that are parallel to CD and contain the point A. So let's take here. So here's line CD, and it has to contain point A, which is right here. So it has to be parallel to that. So it looks to me like AB is the only one that would be parallel to that and contain that. Okay, just like that. B says a skew line to CD that contains the point A. So again, here is line CD, and here's point A, and it has to be skew. So there's a couple of different options that you could have. You could do this line here, because that would go on forever, and those would never intersect. Or you could do this line here, because that would go through A, and that would never intersect that as well. So for those ones, you can either say AH, which is what we mentioned before, or you could say AG. Okay, and again, looking at the picture, here is the original line that we're trying to go skew from, and we have to go through point A. So we can either go straight up, or we can go kind of like skewed this way, but both of those are skewed lines. Okay, C, it says lines perpendicular to CD and containing point A. Okay, so again, here's line, here is line CD, and we're containing the point A, and it has to be perpendicular. So the only one that we can do that looks like maybe AH would be the one that would work for us on that one there. Okay, so we're going to say AH. And notice that we're saying line AH. Okay, and then planes parallel to EFG. So let's make sure we got EFG down. So here's EFG, sort of in the bottom one here. So here's that bottom plane. What plane is parallel and contains point A? Well, it looks like this top plane would be parallel and contain the point A. So I would call that with A, B, C. Remember, you only need 3 points to name a plane. Okay? All right, so there it is. That's everything you need from box 2. All right, so box 3 and 4 are kind of right next to each other. The parallel postulate just says the following. It says if there is a line and a point that's not on the line, then there is only one line that goes through that point and parallel to the line. So here, let me break it down for you, right? Let's call this line M, and we'll call this line M down here as well. And we'll call this point P, and we'll call this point P. So what this is saying, the parallel postulate, what it is saying is there can only exist one line that is parallel to line M and at the same time goes through P. Only one. Only one line. Okay, and the same thing works for being perpendicular, right? There's only one line that can be perpendicular that goes through point P and line M. Only one. There's only one line that can do that. And we just figured it out right there. So that's like a quick little postulate saying that it's pretty obvious, but that we can only have one line that can be parallel and go through a point, and one line that can be perpendicular and go through a point. Okay, fourth and final box here. It just says, the given line markings show how the roads in a town are related to one another. So it says, name a pair of parallel lines, okay? So the ones that are parallel here, so you can see over in here, let me get my laser pointer out for you. Okay, these lines right here, these little markings indicate that which ones are parallel, okay? So this street right here is parallel to that street right there because of the markings. So we're going to say, for number one, we're going to say MD is parallel to FE. Okay. Name a pair of perpendicular lines. Well, because of the markings right here, this is that marking again, right? We're going to say MD, which is this line here. Oops, sorry. MD is perpendicular to BF. And remember, these are lines, so you have to have the little arrows that show that there are lines, okay? And then last one, it says, is FE, so is line FE, so that would be here, is that line parallel to AC? And definitely not. FE is not parallel to AC because by the parallel postulate, we know it can only have one line that can go through it, and we already know that this line is parallel to FD, so that means that this one cannot be. So the answer is no for everything I just said up above. So definitely not, because we know from the perpendicular postulate that if I've got this line FE, right, and I already know that this line, which is BF, is perpendicular to it because of the line right there, it cannot be true that the other line is perpendicular to it. So that's what you would say for that. Okay, that's everything for this first lesson.